Welcome to everyone. Now I am going to discuss some questions on electrical experiment. First I am going to discuss about the RLC series circuit. First question, what is series circuit? When the components RLC or RL or RC are connected end to end, then it is called the series circuit. This is the end 1, this is the end 2, this is the end 1, this is the end 2, this is the end 1, this is the end 2. So the components are connected end to end. So this and last two terminals are connected with the supply, then it is called the series circuit. Next question, what is the impedance? It is known to you very well, but I am discussing again. The impedance is the total opposition offered by the circuit. Total opposition offered by the circuit is known as impedance. Impedance, its unit, its symbol is Z. Here you see Z is the symbol of impedance, and formula Z for the RLC circuit, R square plus XL minus XC whole square. This is the impedance, formula of impedance, and unit of the impedance is ohm. And next question, state the units of impedance. Units of impedance: inductive reactance, capacitive reactance, active power, reactive power, apparent power, resistance, resistance. Impedance unit is ohm. Inductive reactance ohm, capacitive reactance ohm, active power watt or kilowatt, reactive power that means reactive power unit হচ্ছে VAR volt ampere reactive or kilovolt ampere reactive, and apparent power হচ্ছে volt ampere or kilovolt ampere. These are the units, very very important. You can remember very well, very important. These are the very very important units for your placement purpose or for your examination purpose. So you keep it in your mind very seriously. Next question, in RC, RLC and RLC series circuit, what will be the nature of power factor? Very very important question. RC circuit, in RC circuit the current leads current leads the voltage by 90 degree. That means voltage lag behind the currents by 90 degree. And RLC, what is the nature? And here, if the value of voltage across the inductance is less than the voltage across the capacitance, then the power factor is leading nature. If the capacitive voltage across the inductance is more than the voltage across the capacitance, then the nature of the power factor is lagging power factor. And when R and L in series, then the nature of power factor is lagging power factor. That means when R and C is series, then leading power factor. When R and L is series, then lagging power factor. And when R and C is series, then the power factor may be lagging or leading. This depends upon the value of voltage across the inductive reactance, voltage across the inductance, or and voltage across the capacitance. Next, state the kind of ammeter, voltmeter, and how you will identify the kinds of ammeter and voltmeter. Analog type. Analog type. Analog type. You see here, I am showing here one symbol. This is the ammeter. This is the ammeter. Ammeter. Here, this is the ammeter. 1 minute. This is the ammeter. Ammeter. Here, if in front of ammeter, we can see by the glass font size this symbol. If the symbol is given, this is the MI type ammeter. That means this ammeter can be used for both AC and DC quantity, that AC and DC current measurement purpose. This is the MI symbol. MI symbol. By this symbol we can tell easily this is the MI type ammeter. Or here one symbol, another symbol we can give here, another symbol here. This is the M for ammeter, another symbol. This means the ammeter can be used for both AC and DC. You remember it. But what is the symbol for only DC? What is the symbol only for DC? This type of symbol for ammeter or voltmeter. This symbol may be given inside the voltmeter. That voltmeter will be MI type. This type of symbol may be given on voltmeter. That voltmeter is known as MI type voltmeter. And this is the symbol only for DC. This symbol may be given in front of ammeter or voltmeter. By this symbol we can tell this is the moving coil instrument. That means this instrument can be used in only DC supply. That means if it is ammeter, this will measure only direct current. If it is voltmeter, then it will measure the DC voltage. Please keep it in your mind very carefully. And how you will select the range of multimeter. Here you see the multimeter has you see the multimeter here this is the off, here 6, here this side AC, this side AC, here 600, here 200. This is the AC, and the DC 2 volt, here 12 volt, 2 volt, either 12 volt, 20 volt, 20 here 20 volt, here 200 volt. These are the and here 600 volt. These are the DC, here AC. This is the range of the selection of range of the multimeter is very important, otherwise it will burnt out. And when you will do your experiment, you should prepare the apparatus table. You will write what type of ammeter, voltmeter you have used, and you should mention the range. Say ammeter, you will write ammeter range 0 to 5 ammeter. How many number? 1 number. This is the complete specification of ammeter. And type MI type or MC type, MI or MC type. And voltmeter also you will mention the 0 to 300 volt or 0 to 500 volt as per the range, and should be mentioned the type and quantity. Otherwise your apparatus table will be wrong, because without mentioning the range of meter we cannot understand what type of ammeter, what was the range. And circuit diagram should be correct. Without correct circuit diagram you cannot do your experiment. So circuit should be correct, apparatus table should be correct, and observation table should be drawn. When you will report writing, before doing your experiment, you should complete your circuit diagram, apparatus table, and apparatus table should be completed with the apparatus, name of the apparatus, range of the apparatus, and type of the apparatus, how many numbers apparatus you have used. Say ammeter, how many number? 1 number. Voltmeter, how many number? 1 number. Multimeter, how many number? 1 number. Like this. So apparatus table should be complete before going to experiment, and observation table you have to be drawn when you will write. After that you will go for the experiment, and during experiment you will fill the apparatus table. I am telling again, you have to complete your lab report. First you will write name of the experiment, your objectives, then you will write brief theory about the your experiment. Then you will draw the circuit diagram neat and clean by the help of pencil, because you can erase. If you will draw the pencil, you can erase where may be wrong. And then you have to draw the apparatus table and observation table, but apparatus table should be completed this time before going to experiment. When you will go for experiment, then you will fill the observation table. Without experiment you cannot fulfill the observation table. Then after taking the observation, that means data, you have to complete the calculation, and after calculation you will write the you will do the graph, and you will write the discussion part, and you have to appear for the Viva examination. Then you will take permission from your teacher to leave the lab. Don't forget to submit your copy. Don't copy from other students. If we will see you are try to copy from the other students circuit diagram, or you are taking the help from the other students, then you may rejected from the examination or experiment. So be careful. You don't leave the examination hall without giving your Viva. Do you know what is the total marks? Total marks is 60. It will be converted into 100 marks. Your report writing 20 marks, experiment 20 marks, and Viva 20 marks. So all are equal values. So don't neglect. Now I am going to discuss again the questions. What are the common apparatus you have used for the experiment RLC, RC, and RL series circuit? Make a list of apparatus for this experiment with proper specification. has already discussed. What will be the nature of power factor for the AC circuit, pure resistive, inductive and capacitive circuit? Draw the circuit diagram. Next question, define impedance, power factor, already discussed. True power, apparent, already discussed. True power, apparent power, reactive power, inductive reactance, capacitive reactance. What is the unit? What is the formula of RMS value, form factor, average value, maximum value of AC? I am telling again, what is the formula of RMS value, form factor, average value, maximum value of AC for calculating? What is the difference between AC and DC? This is the very important question. How we will connect voltmeter and ammeter, ammeter and wattmeter? How you will connect voltmeter? Voltmeter will be connected in parallel with the supply. Ammeter will be connected in series with the load. Wattmeter current coil. Wattmeter has two coil. One is the current coil, another is the pressure coil. You see, wattmeter has two coil. One is the current coil, another is the pressure coil. Current coil CC, pressure coil PC. Pressure coil PC. This is the pressure coil PC. Pressure coil. You see, the current coil is less number of turns. It has low resistance, and pressure coil higher number of turns. It has high resistance. So in this way, you have to connect the current coil, and current coil you have to connect with the load, and pressure coil is connected with the phase and neutral or two phases. If the pressure coil capacity is more than 220 or 300, then the pressure coil should be connected with the two phase. That means R phase or B phase, R phase or Y phase. Okay, this type of connection, this is the connection of wattmeter. Don't do the mistake. Next question, calibration. What do you understand by calibration? What percentage of error can be allowed? Answer, 5%. What is the formula to calculate the error? Error calculation formula, it is known to you very well. I am now writing here calculation. Percentage of error is equal to say ammeter standard minus ammeter test by ammeter test minus standard, ammeter standard by ammeter standard into 100. It is known to you very well, the formula. Formula, ammeter, if it is ammeter, then you will write the percentage of error is equal to ammeter test minus standard by standard into 100. This is the formula. How you will connect ammeter for the ammeter calibration? We need two ammeters. So two ammeters will be connected in series with the load. Two ammeter will be connected in series with the load. Here the connection diagram I am showing. Here two ammeter, this is the standard, this is the test meter, are connected in series with the load, say 200 watt lamp. This is the circuit diagram. And when you will do the calibration of wattmeter, it is known to you the how you will connect the wattmeter, and you will you take that wattmeter is test wattmeter, and you will use one ammeter and voltmeter. And ammeter, it is known to you P is equal to VI for DC circuit, P is equal to VI. Then this is the standard. This is the standard and standard value of watt and wattmeter reading will be test value, and formula is same. How we will connect the wattmeter for calibration? It has already been discussed. What do you mean by MF and how you will calculate the MF? MF means multiplication factor. This is very important. Multiplication factor means the wattmeter, say wattmeter here 5 ampere or 10 ampere range. Wattmeter 0 to say scale 75. So if you will connect 5 ampere, then multiplication factor, what will be the multiplication factor? Multiplication factor MF. And the wattmeter has connected with the 300 volt, say 300 volt. The pressure coil connected 300 volt, you write 300 volt, and ampere range 500 and full scale 75. The MF is equal to 300 into 5 by 75. This is the multiplication factor. Remember, the wattmeter will not show actual power, so it should be multiplied by multiplication factor, then we will get the actual value. Remember it. If it is digital wattmeter, then it will give direct reading, but analog meter, for analog meter you have to be multiplied by the multiplication factor. Remember it. Next question. How you will take reading for calibration? How you will take reading for the calibration after making the circuit correctly? After completed your circuit, you will how you will take reading I have discussed already. So I am going to next question. How will connect how will draw the curve at the for the calibration? It has already discussed. What will be the discussion after finding the calibration? How you will give your discussion, how you will write your discussion after finding the error? So you will write, if suppose your calibration result is 6%, so you will write the discussion part that since the calibration result is more than 5%, so the meter can be rejected. Okay, meter can be rejected. Now three-phase power measurement question. What do you understand by three-phase? Three-phase means RYB. Here RYB. R means red, Y means yellow, B means blue. Next question. Why we will be using 2 watt meter instead of 3 watt meter? Because it is cheaper than the 3 watt meter method. It is cheaper than the 3 watt meter method. 3 watt meter, if we will use 3 watt meter, so the cost of 1 meter will increase instead of 2. That is why we are using 2 watt meter method. What do you understand by 3-phase 4-wire system? In this system, you see here, this is the R, this is the Y, this is the B, or this is the N. Here this is the R phase, this is the Y phase, this is the B phase, this is the N phase. Here you see the R, Y, B, 3 phases. and neutral. This system is known as three-phase four-wire system. Three-phase four-wire system. This system is known as three-phase four-wire system. Next question. Why? What do you mean by star and delta connection? Very important. Star connection. You see the connection. I am going to draw the connection here. Star connection and delta connection. This is the star connection. Here, this is the star connection. 120 degree apart. 120 degree apart. This is the star connection. This is the say lamp 1, lamp 2, lamp 3. This is called the star point. This is the star connection. We are giving the connection here. This say it is R connection. Say it is Y connection. Here is B phase, and this is the star point. Okay, this is the star point, and we can measure the neutral current here. If it is unbalanced load, say it is 100 watt, it is 200 watt, it is 100 watt. So this type of load is called the unbalanced load. Here we can measure the neutral current IN by the help of ammeter. And delta connection. See the delta connection. Here, this is the one end here. This is the delta connection. Here we are giving phase 1, here giving phase 2, here giving phase 3. So this is the R phase, this is the Y phase, this is the B phase. This is called the delta connection. Clear? I think that all of you clear. How you will connect the 2 watt meter for the measurement of 3-phase power? I have discussed already. For the connection of 2 watt meter method, I have given the connection here with load 2 watt meter. Write a list of apparatus for the experiment. Watt meter 2 numbers, ammeter 3 numbers, and 4 numbers. Here 2 watt meter method, you have to measure the 2 watt meter method, you have to measure the current on R phase. How you will connect here? This is the R phase. Here 1 ammeter you have to connect here, and Y phase you have to connect here another ammeter, and B phase you have to connect here another ammeter, here ammeter, 3 ammeters, and neutral side here also another ammeter. So 4 we have required 4 ammeters. If it is unbalanced load or balanced load, we require only 3 ammeters. Here this is the in case of star connection, IL is equal to I phase in star connection, and VL is equal to √3 V phase. This is the relation star connection. And delta connection, IL is equal to √3 I phase. That means it multiplied by √3 delta, and VL is equal to V phase. In delta. This is the difference between the delta connection and star connection. Next question, what is the balance and unbalanced load? I have already discussed. What is the V phase? V phase means the voltage between the phase and neutral. Voltage across phase and neutral is known as phase voltage, and line voltage across 2 phases, any 2 phases, voltage across any 2 phases, voltage across any phase and neutral is known as phase voltage. IL, the IL means IL in delta IL and I phase same. The current is one in one phase is known as the IL or I phase, and delta same. IL in delta case IL should is equal to root 3 I phase. What is the formula to calculate the power factor in three-phase circuit? I have already discussed the formula. Here you see the formula here. Formula cos phi is equal to cos of tan inverse root 3 W1 minus W2. Cos phi is equal to cos of tan inverse root 3 into W1 minus W2 by W1 plus W2. This formula for calculating the power factor in three phase. Next question: how you will measure the VL, IL, V phase, I phase, IN in unbalanced three phase load? Here the circuit. Here is circuit. You see the circuit has shown here measurement of VL, IL, V phase. You see the VL, that means you will measure by the multimeter VL, that means you connect two leads of multimeter VL, that means voltage across the R and Y or R and B or B and Y. You have to measure 3 times. You have to measure 3 times. And V phase, it is discussed the voltage across any phase and neutral. That means R phase and neutral, Y phase and neutral, B phase and neutral. R phase and neutral, B phase and neutral, Y phase and neutral. You will touch the two leads of multimeter. I am telling again, R phase and neutral, Y phase and neutral, B phase and neutral. This is the V phase. And VL across the any two phases, R and Y, R and B, Y and B. And you can fulfill the observation table. Next question, cut section. What is the DC generator and motor? What is the DC generator and motor? Why armature cores are laminated instead of solid core? Reduce the eddy current losses. How you can minimize the hysteresis and eddy current losses? To using laminated cores and for the eddy current losses, and for hysteresis losses we can use the silicon steel. What is KitKat reusable fuse, and where this type of fuse is used? Answer: in ICDP and ICTP. State the formula of full form of ICDP, MCB, MMCB, DB. ICDP iron clad double pole, ICTP iron clad triple pole, MCB miniature circuit breaker, MMCB molded case circuit breaker, DB distribution board. What is the formula of commutator? What is the function of commutator? State the construction of commutator. What is the principle of motor and generator? What is the autotransformer? What is the advantages of autotransformer over two-winding transformer? Next question, what are the main parts of AC and DC machine? You will see your manual, you will get everything. How you will identify the AC and DC motor? Why MCB is used widely nowadays instead of ICTP? What is the function of carbon brushes? What materials is used to separate the commutator segments? What is the function of motor and generator? State the kinds of DC motor and generator. What is the self-excited and separately excited generator? State the kinds of generator for winding connection. What is the Faraday's laws of electromagnetic induction? How you will prepare the lab experimental report I have discussed. Following step I have already told you. What is meant by OCC characteristics of generator? How you will draw the critical resistance? What do you mean by residual magnetism? How you will do experiment? How you will do the experiment at the time of examination? Read carefully all the instruction. Answer. Read carefully all the instruction. Switch off the panel. Switch off the panel. Make the circuit diagram as per your circuit diagram. Check the circuit by your teacher. If it is okay, then you will get chance for the experiment. Take the required data. Complete the calculations and graph phasor diagram. Submit the report after checking. Everything has discussed already. Next question. Questions on open circuit and short circuit test. Why we are performing the open circuit and short circuit test? By which test we are finding iron losses of the transformer, and why the name short circuit test is called. Is it possible to find out the efficiency of the transformer without OCC and SCC test? Why transformers are rated in kVA instead of kilowatt? Next question. How you will draw the efficiency curve? Next question. How you will perform the open circuit test and short circuit test? How you will calibrate the IP, calculate the IP and IS, that means primary current and secondary current, before performing the open circuit and short circuit test? Say Vp is equal to 220 volt, Vs is equal to 110 volt, and rating of the transformer is 500 volt ampere. Question. Next question. A transformer is rated as same as question number 6. What amount of voltage you will apply during the open circuit test? Is it system to apply full rated voltage to primary side during the short circuit test? Give the reason if not. What are the next question? What are the components of I0? Draw the phasor diagram and show the I0. I am repeating again the question number 7. A transformer is rated as same as question number 6. What amount of voltage you will apply during the open circuit test? Is it system to apply full rated voltage to the primary side during short circuit test? Give the reason of if not. Next question. What are the components of I0? Draw the phasor diagram and show the I0, I mu, IW, and write how you will take reading for full load, 3/4 load, full half load, and 1/4 of full load during the short circuit test. And Thevenin theorem and Norton theorem, you will when you will perform the Thevenin, Norton and superposition theorem, when you will find out the Thevenin voltage, then you will open the open the load and you will measure the voltage between the 2 points of load by the help of voltmeter or multimeter. I am repeating again, to measure the Thevenin voltage you will open the load, and where load was connected you take the reading between the 2 points by on the voltage sources. And when you will measure the Thevenin resistance, find out the Thevenin resistance, then you will remove the two sources and short the 2 points of sources, and you will remove the load resistance. Then you will measure the RTH between the 2 points of load. This is the system. The RTH will system of RTH and RN is same. Okay. When you will find out the Norton current, how you will measure? You will open the load and you connect an ammeter, then you on the both source of supply you will get the Norton current. This is the system. And superposition theorem, when you will do the superposition theorem, then you will first open one source of supply, you short circuit, and other you will on, then you will get one ammeter you will connect in series with the load, then you will get one reading. And second step, you will open the previous source of supply and it will be short circuit. Then the previous short circuited source you will connect their source, you on the source, then you take the reading, and you add two readings. Previous I say this is I1 and now say it is I2. So I1 plus I2 is equal to total I. This is the first method. Second method and third method, you will on both sources of supply and you will take one reading. So it will prove that the I1 and I2 is equal to say X ampere. So this X ampere will show when you will apply both sources of supply. So this is the system. Thank you. Best of luck.